Good morning, everybody. Today I'm going to talk about the color and the temperature of a star. So, how do we measure the temperature of a star? How do we measure the temperature of sun? The way we do measure the temperature of the sun, not the moon. You see here, the moon is a different thing here. It's not a star. Here I'm talking only about the stars. So if you just know the color of the star, we can very precisely calculate the temperature, the average temperature of the star just by looking at the color. In this picture, you see, if you have a hot object, that hot object emits the thermal radiation, and the frequency, the wavelength of the emitted radiation depends upon the temperature of the flame. And just by looking at the color of the flame, we can tell how hot it is, what should be the temperature of it. So if you have a hotter object, it emits, the hotter the object is, it emits more light per unit area at all frequencies or all wavelengths. So that means it also has more intensity, or it emits more photons and has a higher average energy. So this picture here, this picture right here is the Hubble Space Telescope photo, and it shows a wide variety of stars. And when you look at the stars in this picture, you see the different colors and the brightness. Most of these stars in this picture are about the same distance, which is about 2000 light years from the center of our galaxy clouds. But the one thing what I would like you to know, point it out, is see the differences in the colors. You see almost all types of colors: the red, the blue, the white, yellow, all sorts of colors. So the color of the star tells you the temperature. The hottest stars have the temperature which is about 50,000 Kelvin. The hottest stars is about 50,000 Kelvin. And 0 degrees Celsius is close to 273 Kelvin. So you see, this is very hot stars, 50,000 Kelvin. The sun temperature, you see how hot sun is. Even on the earth's surface, it is so hot. The sun's surface temperature is about 5800 Kelvin. And I will tell you how did we calculate the sun's temperature. Okay, so the range of the temperature varies from 5800 to, like, let's say 50,000 Kelvin. So this tells you a lot more information about the star's color and temperature. So first we're going to define the color and the temperature, and then we're also going to define the class and the temperature. The hottest stars has the blue colors. So if you see the blue colors here, So in this picture, this blue colors here means this is the hottest stars. These are the hottest stars here, the blue colors. And then the orange, the red colors are slightly cool stars. So if you see, these are the cool stars here. So just by looking at the color of the star, it tells a lot of stars. You can tell directly, oh, this is hot and this is cool. And so if you see in between, like let's say for example, this is yellow, so which is in between. And the color, it doesn't matter where you look at it, you look from the earth or you look from the other star, it doesn't matter. The color does not change. The color is the same. It doesn't change with the distance. So if you see a blue color star, that means the temperature is about 33,000 Kelvin. And if you see the blue to white, which is about 10,000 to 30,000 Kelvin, the white color, so the yellowish white color is about 6,000 to 7,500 Kelvin. So this is where the yellow color is about 5,200 to, this is where the sun temperature is. And this is the class here. So just I would like you just to remember this class of the star here. Okay, so the astronomers classify stars according to the surface temperature by assigning a spectral type. The hottest stars with the blue colors, so the hottest stars with the blue colors are called a spectral type O. So they call the hottest stars the spectral type O, and they call the cool star, the red color star, the spectral type M. So if you see a class of the star, you should just be able to tell it is a cooler or hotter star. The class type O is called hotter star, and the class type M is called a cooler star. Our sun is the class type, a spectral type G star. This is the sun here. This is the sun right there. And then further, the astronomers have further divided each classes into the subcategories. For example, let's say if I just take the class B, the B is divided into B0, B1 till B9. The larger the number, the cooler the star is. For example, if you look at the sun is designated as a spectral type G2. That means in the spectral type G, the sun is hotter than G3 star, but it is cooler than G1 star. Okay, so the larger the number is, the cooler the star is in that class. Okay, so the sun is hotter than G3 star and cooler than G1 star. Okay, now let's go through some thought questions here. Which kind of star is hottest? M star, F star, A star, or K star? In order to answer this question here, I would like you to go back here, see here. So this is the hottest and the temperature decreases here. O is the hottest here, but you don't have O. You have M, F, A, and K. So look, the A is the hottest stars. Among this one, A is the hottest stars. Okay, see, the M is the cooler, F is even cooler than A, so A is the hottest among these stars. Again, so coming back to the same question again, which of these spectral types is the hottest type of a star? So go back to here. Just from this one, this is the hottest one, and as you go down, that's the coolest one. So which one is the hottest one? The B. Go back here, the B. We do not have O here, so B is the hottest stars. So after learning about the finding the temperature of a star, we're going to talk about the in the next chapter in the next lecture I'm going to talk about the HR Hertzsprung-Russell diagram, and this is such an important topic, and I would like you to pay attention on this topic.